Hey everyone, so this is question number 23 from your exam one review. So please again stop the video, read the question and attempt it, all right, before continuing. I think you have all the tools, all right, and most importantly you need to identify what are the keywords, right? Okay. All right, getting back to the question. So what we have here, so again, is a teacher salary. I think is Pearson is obsessed with teacher salaries. All right. So anyway, regardless, the keyword here, the first one is the average. Right. So the word average is obviously 35,441. Right. The second keyword is normal distribution. So you know you are dealing with normal distribution. So what we are missing standard deviation, and actually they wrote sigma instead. Sigma equals to 5100. So that's your sigma standard deviation, right? Now they are talking about 4 decimal places for the answer and 2 decimal places for intermediated z values calculation. Now you don't really need the intermediated value, because we're going to be using the calculator for this method to solve it. And I hope this will help you go faster with the questions, right? Otherwise, it might be a little harder to do it by hand. Now, the question is, we want to figure out the probability of x greater than 36,000. X greater, all right? So let's move on to the whiteboard, put everything there. I think a graph will definitely help us understanding the problem. On the graph, what one of the keyword is saying is a normal distribution. So this is the distribution where we are at, right? We are working on the normal distribution, and normal distribution is again is a bell shape. And this bell shape, because only normal, so you're gonna have the middle where the mean is. They told you the mean is 35,441. The sigma, the standard deviation, is equals to 5100. All right. Because this is just a normal distribution, the axis over here is going to be x-axis. So you are along the axis. And the question is, what is the probability of x greater than 3600? 36,000. All right. All right. So how can we do this one? So again, we need to identify where is the 36,000, right? So if this is 35,441, so the 36,000 is going to be somehow somewhere here on the right hand side, right? So this is going to be your 36,000 location, and let's call it x1 anyway, right? So it's going to be closer to the mean, which is 35,000, because you see it's not really big, only about $559 difference, right? So again, I need to identify whether the x is greater than that value, so I need to go to the right side. All right, so this is the axis, greater than 36, so this is the value. However, I'm looking for the probability, so the probability would be the area bounded by the vertical line here, the graph, and the horizontal line. So this shaded area, that's what I'm looking for. All right, I'm looking for this area in here. All right, that's your question. And so how can I do this one? So it's the same information we need. We're gonna use the normal CDF, cumulative distribution function. That's number 2 on the distributions. We're gonna use the mean and sigma. That's 2 information that we need. We're gonna need the upper bound and lower bound. So the upper bound is obviously this one. This is my upper bound, and my lower bound. So yeah, so let me redo it again. So this is my lower bound. So my lower bound is this one, the 36,000. All right. My upper bound will be somewhere whenever this is gonna keep going to the infinity. So this is going to be the infinity, the upper bound. So the upper bound here is going to be this one, infinity. So the infinity on the calculator again, please remember, is 1e99 because it's positive, so it's going to be positive 1e99. And I think we have everything. So just go to the calculator again. So we go with second, we go to the vars, that's distributions. You go to the second option here, normal CDF, enter. So clear whatever entries there. So the lower bound is 36,000. The upper bound is already there, so 1e99 is fine. We're gonna put the mean, which is, clear this, it's gonna be 35441, and we're gonna go to the standard deviation, which is 5100, and enter. So we're gonna paste it, enter, and that's the probability that you're looking for. So the probability is gonna be 0.45636. We need just 4 digits, so we need to round this one. Whenever you round it, it's gonna be 0.4564. All right, and hopefully this will be your answer. All right, so what we're gonna do is 0 here, 0.4564. All right, check the answer, and congratulations, it's correct. All right, so the next part of the question, they change it, and they are saying there is a sample, and this is another keyword, sample of 40 teachers, right? So sample of 40 teachers, and they change the sample mean. So the sample mean is not the average, right? So the sample mean is that the x1 again bar, right? So it can be 37,249. All right, and they are looking for x bar greater than 37,249. So we have the sample size is 40, we have the x1 bar is 37,249, and we are looking for x bar greater than 37,249. So again, we need to put it on the graph, and before putting it on the calculator, right? So we need to identify the mean, we need to identify the sigma, we need to identify the upper bound and the lower bound. Okay. Okay, so here, what we're gonna do, we are using the central limit theorem. All right. So how do I know I'm using the central limit theorem? Because I'm gonna take this chart here. All right. I'm taking actually this chart here, and I'm doing sampling. And what is the sample size is n equals to 40. All right. So once I do the sampling here, I need to use the central limit theorem. Or what is the central limit theorem is giving you two facts, that the mu x bar, that the new mean will be equals to the old mean, which is the mu, which is the same thing, and the sigma x bar, this would change into the old sigma over here divided by radical n. All right, so this is basically the central limit theorem. Now the distribution that you're gonna get whenever you do the sampling, you're gonna be as well a normal distribution. All right, the mean here of this normal distribution is going to be called mu, the middle, mu x bar, and this is whatever 35,441, and the sigma x bar, all right, this will be the old sigma, which is 5,100. However, you have to divide it by radical 40. And no calculation is necessarily for this. I am usually keeping it as it is. All right. Okay, so I keep it as it is, and I use it in the calculator, right? So the new question right now is asking you, what is the probability of X bar greater than 37,249. All right, so I forgot to tell you that this new axis is going to be called X bar, the sampling axis, right? Okay, so probably the graph is not really clear. I'm going to zoom in a little bit here. All right, so now where could be 37? All right, I'm looking for 37,249. So 37,249. Of course, if this is around 35 here, that's the middle. So 37,249 is going to be somewhere here. 37,249 is going to be somewhere here. And because I am on the X bar again, all right, so I'm going to call this one X1 bar equals. And if I'm looking for the probability, so if I'm looking for the probability of X bar greater than 37,249, therefore I am going to the right side and I am looking for this area. All right, this is the area I'm looking for. So that's basically the new probability. So what I need the mean. I have it. All right, I have the mean already. I have the sigma already. So I need the upper bound and the lower bound. Okay, so the lower bound will be this one. So the lower bound will be this one here, as you see it. The upper bound is going to be somewhere here, which is plus infinity. So the upper is going to be 1e99, which is plus infinity, right? Now, if I go to the calculator, I'm going to put the lower bound. So how do you go to the calculator again? So to go to the calculator, you're going to go second vars, and then you're going to go to the second one, normal CDF, enter. So by default is minus infinity the lower bound, but you need 37 there. So you clear this one, and you're going to put 37249. And then you're going to go to the upper bound, which is 1 E, which is second and comma, that's E, and 99 here. And then you're going to go to the mean, which is 35,441, 35,441. And the standard deviation, which is 5,100. But right now we're going to divide it by radical 40, or you're going to go to second here. The radical sign is above the square, so you're going to be radical sign. You're going to be 40, and don't forget please to close the parentheses, otherwise the calculator will not take it. And then you're going to go to paste, enter, and enter again to get the result. And that's the area. That's it. So the area, or the probability, would be equals to 0.0124 and 7 here. So if I need the 4 decimal points, so you're going to be rounding the 7, and this is going to be 0.0128, and this is it, right? So this is your answer. Actually it's not 8, I made a mistake here. It's not 8, it's actually 5. So 0.0125. All right, let's go back and plug it in and check it. Okay, as you see here, I just already plugged in, so I put the answer 0.0125, and it came up correct, which is very nice. I hope you make a difference already between the sampling and the normal distribution without sampling. All right. Okay.